Hi guys, we're gonna try this. You know I'm actually terrible at trig or right triangle problems, so this is the hardest version. So we're gonna try and we're gonna see how far we can get. Baby cat player two. Okay, let's try. Where did mine? Where'd it go? Here it is. Okay. Consider isosceles right triangle ABC. Okay, isosceles right triangles are easy. Isosceles right triangle ABC with a right angle C. Okay, so C A B C. Okay, cool. I'm gonna do this better. Isosceles right triangle ABC. A, B, C. This is a right angle, and this is the same as this. And square FCML such that F is on AC. So F is on AC, so let's say F is here. FC, so M is on BC. M, and L. And then this is the same as this, is the same as this, is the same as this. And L lies inside the triangle. Okay. If the area of the triangle ABC is 2025 and the distance from L to AB is 25, find the area of FCML. Okay. First, let's find information about the isosceles right triangle given the area. So we know the area of the triangle is going to be, let's call this L, is going to be L squared over 2. So 20, 25, let's put a L squared over 2. This is equal to 45 squared. 45 squared is equal to L squared over 2. So 2 times 45 squared is equal to L squared. So L is going to be equal to square root of 2 times 45. Okay. Um, so then that means that this is 90, I think. I think it's just times square root of 2. Because if, let's say if we flip this and we have this angle, uh, this is 1 and this is root 2 over 2. So, to get this to be 1, you multiply it by root 2. Yeah, so multiply it by root 2. So, hypotenuse is equal to 90, because this is times root 2, so this would be 2 times 45. Okay. Find the area of FCML, so we just need to find the length of one of them. So if we know, uh, huh, we have this right triangle. We draw a line from here to here bisecting this, where this should be right angle, but it's not right angle. This should be right angle, this should be right angle. This is the same as this. Um, then L is going to be on here somewhere. So L is going to be like here. What do we know about L and FC? The area of the triangle ABC. Oh, the distance is 25. Okay. So if we know the distance from L to AB, this is 25. So if we know the entire distance here, if we know this entire distance, then we can find this one here. We could use that to find one side length, which then we could use to find the area. Okay. So how do we find this entire distance? Well, if we cut it in half, it's going to be half the area. These are going to be two isosceles right triangles again. So maybe we just do the same thing, we use the area to get a side length. So if we have half the area, so half of 2025 is 2025. Oops. 2025 over 2 is going to be equal to, we're going to call this distance. Distance squared over 2. Right, this thing times this thing over 2. So then that means that distance squared is equal to 2025. So distance is going to be equal to 25. So then that means that distance minus 25, 45 here, is equal to 20. So that 20 is this right here, 20. So now we just need to use diagonal to get area. If this is 20, then this is a square. So hypotenuse to side length is times root 2 over 2. So 20 times square root 2 over 2 is going to be equal to 10 root 2. 10 root 2 squared is equal to 100 times 2 is going to be equal to 200. I believe this is correct. I don't see where I could have gone wrong here. Let me check. Let me check. I did in fact get it right. I got it right. I got it correct. Wow, great job. Kind of surprised I got that right, to be honest, because I was not expecting to. This is a right triangle question. I'm not very good at right triangles, but I didn't really have to worry about angles this time, which is probably why. So maybe I just need to study angles in the future, because this problem wasn't all too difficult. It was not all too difficult. Thank you guys for watching. I will see you guys tomorrow. Bye.